lesson 1, 2, 3. Areas of sum and product and sum. And again, this is a review from Integrated 1, but it is so important for what we're going to do with parabolas later in this book. So I really hope you guys make sure you understand how to do this. Ask questions if you don't. Honestly, it starts with some stuff that's not even really super important, and I kind of even hesitate to go through this, but I hope that we all remember the shape, right? The little square was a 1. Then we had like kind of the rectangular shapes of the x, y. The x was the shorter side, the y was the longer side. Then we had the squares that were y squared and x squared. Again, the x squared was smaller. And then we just had an x or a y, which is like an x times a 1 or a y times a 1. So what it asks us to do over here is to figure out the perimeter and the area of these sides. And again, when I do these, the perimeter is always more difficult than the area. The area is always pretty simple. So I'll go ahead and do the harder one first. I'll start with the perimeter. So this is a 1, a 1. It looks like if this is an x, this is probably an x, right? So, if only I had good handwriting. So this looks like an x by x square. So this would be a 1, again, because it's an x by 1. This will be an x, 1, 1, 1, x. This gets a little tricky. Like, I know this is a 1, 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 but what is this? Hopefully we all recognize this as this thing as an x minus 2. Right, if this whole thing was 5 and 2 was taken away, we would say that this part would be 3. Well, that's what x minus 2 says, is 5 minus 2. So hopefully that makes sense. Now, if I have the perimeter, again, I'm starting here. So I'll count my x's. I have 1, 2, 3, 4 x's. And then my 1's, I have 1, 2, 3, 4, 5, 6, 7, 8. Minus 2 is 6, 7, 8, 9, 10. So I get 4x plus 10. My area, pretty simple. I have 1x squared. Right? I have 1, 2, 3 x's. And I have 1, 2, 3 1's. So if I want to go here and do my perimeter and my area, my perimeter on this one is going to be a y. Right? This looks like a y. An x, an x, an x, an x, an x. This right here, hopefully we all recognize. Again, it's a y minus an x. If this thing was 10 and an x was 8, we would say it's 10 minus 8 is 2, and that's what we'd get right there. Here's a 1. Here's, got some issues. Here I have y minus 2. So again, if this whole thing was 10, I've taken 2 away, so y minus 2. 1, 1, 1, 1, 1, and y. So what's my perimeter? I'll go with x first. So 1, 2, 3, 4, 5 x's minus 1x, so I get 4x. My y's, I have 1y, 2y's, 3y's, 4y's. My 1's, 1 minus 2 is negative 1, so I'm back to 0. 1, 2, 3, 4. So that becomes my perimeter. And my area, again, I have 2x squareds, right? These are 2x squareds. I have 1y squared. I have 1y. And then I have plus 2. So it's going to look something like that. So use the collection of algebra tiles at right to complete the following problems. Arrange the algebra tiles into one large rectangle. It has to be a rectangle or a square. It can't be a shape like this, which is why I'm kind of like, what do we do it this way first? But whatever. So we're going to go ahead and we are going to decide what these look like and as a rectangle with x squared tile in one of the corners. Remember to flip the algebra tile so that the positive sides of each tile is facing up. On your paper, sketch what the rectangle looks like. The area of a rectangle can be written as the sum of the areas of its parts. Write the area of a rectangle as the sum of its parts. Simplify your expression for the sum of the rectangle's parts. The area of a rectangle can be written as length times width. So hopefully you guys remember this from Integrated 1, right? We had area as a sum and area as a product. Sum means addition, product means multiply. So I'm going to read through this and then talk about what we mean, and then we'll go show it. So it says the area of a rectangle can be written as length times width. What are the dimensions, length and width of the overall rectangle you made? label your sketch with the dimensions, then write the area of the rectangle as a product that is length times width, and write an equation that shows what the area written as a sum is equivalent to the area written as a product. So what does all of this mean? So here's what this means, and again, I will kind of go back over here and get this stuff all back in a second, but what they're saying essentially is this. If you had a rectangle that was 3 by 4, right? If I wanted it as a sum, and again, a sum means plus, I would just say, oh look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I added up the middle. And that should equal the product. I don't know what's going on with that. That doesn't give me a lot of hope for this video saving. Anyways, again, product means multiply. Well, I could call this 12, or I could call this 3 times 4, right? You see 1, 2, 3 on this side and 1, 2, 3, 4 on this side. So I could also call it 3 times 4. So that's what this is saying. It's saying, hey, take these shapes, put them into a rectangle, tell me what the middle adds up to as a sum, and then tell me what the sides are times each other. And this sum should equal this product. That's what we're going to be doing right now. So let me go ahead and reopen a new one to get a clean one here. So you can see we have this stuff right here, and I'm going to go ahead and jot these down. Actually, I'll just run back and forth. So I have x squared plus 8x plus 12. So what I'm doing here is I'm going to go back over into this, and it tells me to open these algebra tiles. And what it's done is it tells me I have 1x squared, I have 8 x's, so I'll go ahead and I'll put 8 x's, and then I have 12. So I'm going to pause this while I put all this out because I have a bunch of stuff to put out, sorry. So I would kind of argue that this isn't a great problem to start with. There's a lot of stuff out here, but like it says, make sure you have an x squared in the corner. And then what I like to do is I like to be real organized about the way I do this. So I'm just going to put all these x's up here, and I know that I have to get a rectangle that looks exactly right. And I know that it's never going to happen because these ones are not allowed to equal an x, even if it looks like they do. You can see they don't, but even if it looked like they did, we're just simply not allowed to do that. So when I go ahead and line these things up, I'm not going to get a rectangle out of this shape. So I'm going to go ahead, I'll finish this off just to prove it. But you can see like that doesn't make a rectangle. So one by one, I'm going to start dropping these. And if I double click these x's, they move down. I'll move some of these ones out of the way. So what happens if I move this here to line this up, right? I go ahead and I move all these over, and you can see I'm still not going to get a rectangle out of this. So that didn't quite get it. What if I drop another one? Put this down here, and now there we go. There's my rectangle. So when we look at this shape, I want you to remember what the shape is. I have an x squared plus 1, 2, 3, 4, 5, 6, 7, 8 x's plus 2, 4, 6, 8, 10, 12, which is kind of funny because whether we knew this or not, I don't understand why that just closed. But whether we knew this or not, this is already written as a sum. This is a sum. Those are the blocks that I used, right? Those are the shapes I had. But what is this as a product? Well, as a product, this is going to be x plus 2. I'm not allowed to write it. I can't write on this. So x plus 2 and x times 1, 2, 3, 4, 5, 6. So I get x times 2, x times 6. I'm sorry, x plus 2, x plus 6. That's what I'm going to get as a product. The side times the side of x plus 2 times the side of x plus 6 equals x squared plus 8x plus 12. The side of x plus 2 times the side of x plus 6 equals x squared plus 8x plus 12. All right, let me run over here and set up the next one, 4x squared plus 4x. So I'll go over here and set that up, 4x squared plus 4x. Squared plus 4x. So if you go ahead and look over here, you'll see I have my 4x squared plus my 4x. Well, I think this one's going to be pretty easy to do. I hope we all see what I can do there. As there's my 4x squared plus 4x. But you'll notice what I have here is 1, 2, 3, 4 x's times x plus 1. So I will say this is equal to 4x's times x plus 1. Again, this is my product, or my sum, which is adding, and this is my product, which is multiplying. Now we'll go 2x squared plus 7x plus 1. So let me go ahead and set that up. 2x squared plus 7x plus 1 over on the other page. Plus 7x plus 1. So we'll go over here. There's my 2x squared plus 7x plus 1. You'll notice I sort of leave the extras over here. It's just kind of a pain to drag them out. That's why. All right, so like I said, I will go ahead and just sort of put all these things up here. It doesn't look like it's going terribly well for me there. So what if I start spinning some of these things and putting them down here? Will I have any luck? That doesn't seem to have done it. So let's go ahead and I don't know. So I'm going to make sure I have the right one here. 2x squared plus 7x plus 1. Alright, so I'm not having a lot of success with this. So let me play with this for a second. I wonder if there is even a solution. There might not be. Look, you got me. There is no solution to this one. So not all of these can be turned into a rectangle. So this one is not. So there is no solution on this one. And if we go to this one, x squared plus 2x plus y squared, let's go ahead and set that up. X squared plus 2xy plus y squared. So x squared plus 2xy plus y squared is, I believe, what we're coming up with here. Let me double check that again. So x squared plus 2xy plus y squared. All right, so how am I going to turn this into one? Maybe something like that. All right, so we can see we have x plus y, x plus y. And that's what that's going to turn into. So this will equal x plus y times x plus y. All right, so that takes us through problem 44. Let me go ahead and set up the next problem. It says using the diagram, write the equation that shows the area of the rectangle written as a sum and as a product. Well, again, the sum just means add, so we can literally just look at that, and the product means multiply, so we'll figure out what the sides are. But the sum should be pretty easy. Here I have 6x squareds plus 4x's plus 9 more x's, so that's a grand total of 13 x's plus 6, and that will be equal to the side times the side. So let's go ahead and figure out what the sides are. Here we're going to say 1, 1, x, 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 so we'll call that 3x plus 2. And here we will say it is x, x, 1, 2, 3. So we'll say that is 2x plus 3. So there we go. And then you might remember also from integrated 1 that we use these area models kind of as a shortcut. So if you think about this, we can really rewrite this. This right here is 3x. This right here is 2. This right here is 2x. And this right here is 3. So what is 3x times 2x? Well, we should get 6x squared. And you can see we just sort of get rid of all the algebra tiles, and 2x times 3x is 6x squared. You can literally see 1, 2, 3, 4, 5, 6x squared. And what about 2x times 2? Well, we get 4x, and there you go, 4x. 2x times 2 is 4x. So you just start multiplying these pieces together. So here, 3 times 2 is 6. You'll see you literally have 6. And then here, 3x times 3 is 9x. And again, you see that you literally have 3x times 3 is 3, 6, and 9x. So we're going to use these area models kind of as a shortcut to using all those things. So then we get into some puzzles here, which is kind of fun. So x times what equals 3x squared? Well, this would have to be 3x, right? 3x times x is 3x squared. And then 3x times 2 would have to equal 6x. So we can write this as, and we should write it as a product as in a sum, right? So it's 3x times x plus 2 is equal to 3x squared plus 6x. And again, I cannot tell you how important this is. We're literally looking at parabolic shapes, and I'll show you what I mean in a minute when I'm done kind of going over these, just as a look forward to where we're going to head. So x times x is x squared, 1 times x is x times something is x times 1 is x, and 1 times 1 is 1. So if we look at this, it's x plus 1 times x plus 1, and that is going to be equal to x squared plus 2x plus 1. This might be the one that I use in my example later. If we go here, okay, I know that 2 times negative 2 is negative 4, but I need to throw an x in there. I know 3y times x is 3xy. This will give me negative 2x squared, right? Hopefully you see you're just multiplying the bottom by the side. 2 times negative 5 is negative 10. 2 times 3y is 6y. And then I get negative 5x. And don't forget, you need to combine like terms. So on this one, I'll have x plus 2 times negative 2x plus 3y minus 5 is equal to, here, negative 2x squared. There's no xy's, so plus 3xy minus 5x minus 4x, that's minus 9x plus 6y minus 10. So you do need to combine like terms. Here, 2x times what? Well, 2x times 2x is 4x squared. Here, 2x times 3 is 6x. 3 times negative 3, and then negative 3 times 2x is negative 6x. So on this one, we will get 2x minus 3 times 2x plus 3 is equal to 4x squared. These will cancel, 6x minus 6x goes away, minus 9. By the way, it doesn't matter if you would have written this as 2x plus 3 times 2x minus 3 is equal to 4x squared minus 9. That would have been fine as well. But let me show you what I'm looking at here. My point is this, that this what we're doing right here is going to be super important later in the year. So let me go ahead and set up Desmos and show you what I'm talking about. Focus on this. This y equals x plus 1, and y equals x squared plus 2x plus 1. So if I go over to Desmos, you can see y equals x plus 1, and y equals x squared plus 2x plus 1. I'm both saying that they equal each other and they both equal y. Well, look what shape they make. They make the shape of a parabola. What if I grab this one? It's the exact same parabola. So this seems to be something that a lot of kids really struggle with that is so important in this class. This is a parabola. It's the same parabola in different equations, because sometimes we'll get it looking like this and we'll be able to graph it, and sometimes we'll get it looking like this and we'll be able to graph it. So the more we know about these parabolas, the more it's going to help. Now, I don't expect you to know how to graph these things. That's not important for right now. We're going to add that as the year goes on. But I don't want you to look at this lesson and think, who cares? This doesn't have anything to do with anything. It has a lot to do with what we're going to do later in this chapter, or in this book, I should say. So make sure you really understand it. All right, now it says make a rectangle from any number of tiles. The rectangle must contain at least one of the following tiles. Sketch, or I don't really honestly feel like doing this, so we will be done with lesson 1, 2, 3.